I'm Kirk Harnack. On This Week in Radio Tech, we explore the tech behind the APHEX Aural Exciter and the Big Bottom, staples of audio production, with Tom Ray, Chris Tarr, and our guests Marvin Caesar and Rob Arbittier. On This Week in Radio Tech, next.
Netcasts you love.
From people you trust.
This is TWiT.
Bandwidth for This Week in Radio Tech is brought to you by Cachefly at CACHEFLY.com.
This is This Week in Radio Tech, episode 121, recorded March 21st, 2012. Big Bottoms and Aural Excitement. This Week in Radio Tech is brought to you by Axia Audio and the new Radius IP audio console on the web at axiaaudio.com. Hi there and welcome in. It's This Week in Radio Tech. I'm Kirk Harnack, your host. Glad that you are along with us. This is the show where we talk about radio technology, all the things that go from, hey, the stylus on the microphone tone arm, if you still have those, all the way to the top of the tower. And we've got a really good show for you. I know we have a good show every week. We have got an awesome show this week because we're going to find out some stuff, some secret magic stuff that I am just dying to know. But first, let's introduce our usual co-hosts. I'm Kirk Harnack. My employers, Telos, Omnia, and Axia. They're also one of the sponsors of this show, so thanks very much to Telos, Omnia, and Axia for that. Also with us from the Hudson Valley of New York, it is our intrepid engineer, Tom Ray, the Director of Engineering for Buckley Broadcasting. Hey, Tom, how are you?
Hey, greetings, Kirk. Fine. Just, sitting here and relating to this dummy load. It's perfect for me. But anyway, how are you tonight?
I'm great. And thank you for the advice you gave me in the last week or so about buying some ham gear. I got my general license months ago over in Petaluma, California. In fact, at the very building that this show is being produced at at the TWiT network. And I haven't bought any ham gear yet, so I ordered it last week. Should be in when I arrive back from my little vacay.
Well, let Chris and I know when you have things ready to go, and we can harass you. It'll be great.
Can you harass me on ham radio? Is that how that works?
Yes, it's completely legal. I've checked it out.
All right. Speaking of completely legal, let's check in with Chris Tarr in Mukwonago, Wisconsin. Are you ever going to move, or you just really like it there in Mukwonago?
I love it here.
All right.
My question for Tom is when did we stop harassing you? I didn't realize that there was a time we were supposed to start. I've been doing it all along, so I don't know about that. I am the Director of Engineering.
Medium.
I am the Director of Engineering for Intercom's radio stations in Madison and Milwaukee, Wisconsin. I also am a contributing writer to Radio Guide magazine, and also run the co-owner of the website broadcastengineering.info.
Cool. And Chris, thank you also for your advice this past week on the ham radio gear. I appreciate you taking a few minutes out to tell me what to buy. We'll see how it works when I get it all hooked up. I just got to make sure I get the power and the antenna in the right holes on the back of the transceiver.
Well, if you don't do that, the smoke will come out. You'll be all set. Yep. You'll know exactly what you did.
That's right. All right, let's bring in our guests. We have a panel of semi-experts, so let's bring in our guests here. A guy who I met quite a few years ago, actually, a fellow named Marvin Caesar. Marvin is talking to us this evening from the studios of his friend Rob Arbittier. Arbittier.
Rob Arbittier. But pronounce it however you like. Just don't call him late for dinner.
Marvin is the founder of APHEX Systems, a company which I guess until somewhat recently he ran day to day. And if you've ever heard of the APHEX Aural Exciter, well, that's the technology that Marvin is responsible for promoting and turning into a terrific tool for broadcasters and recording studios alike to use. So, hey, I'm sorry, I didn't mean to blah, blah, blah. Hi, Marvin. Thanks for being with us this evening, and I appreciate you being here.
It's great to be here.
With Marvin is his friend, Rob Arbittier. Rob, tell us a little bit about you and Noisy Neighbors.
Well, Noisy Neighbors is my production company. I'm a composer and producer. I've been Stevie Wonder's programmer for about 26 years, and I have my own facility. That's what's called Noisy Neighbors. That's what we're sitting in right now. And we do everything from music composition, recording, producing, mastering, all of it. And we've been using the APHEX gear since long before I ever actually met Marvin. But we're actually neighbors as well as industry buddies, and we've always had a lot to talk about.
Well, he primarily comes here over to my place and eats.
Yeah. He can cook and I can mix, so it's perfect.
So tell you what, before we get into the older history, because I really want to know about the genesis of this aural exciter. I'm given to understand it was a bit of an accident, and then it turned into this fabulous tool that so many people use, and everybody on the planet who's ever listened to a song on the radio has probably heard something going through an APHEX Aural Exciter. But Marvin, if you would, just catch us up on your real recent history. You were the founder of that company, but you're really no longer associated with that. Is that right?
That is correct. I sold the company in May of 2010, and I had to sign a non-compete. So I have a while to go on that non-compete, and so I've been busying myself with redoing my kitchen, redoing the pool, doing a lot of mountain biking, cooking for Rob.
These are all big money makers for him, as you can imagine.
And generally having a good time.
Well, cool. Okay, so now we know what the current stuff going on is. First of all, well, I'll tell you what. I'd like to hear about the genesis of this aural exciter, spelled A-U-R-A-L, right? Aural, like audio, aural, exciter. And well, how did this come to be? I heard a story about somebody put a kit together wrong, but it sounded good.
Well, from the story I heard back in 1975, when I met the inventor of the aural exciter, who was a Swedish guy named Kirk, he said that he had a heath kit and he miswired one of the channels, and it was this strange, distorted sound out of that one channel. And then when he added that one channel, that distorted channel, to the correctly wired channel, all of a sudden it was a cleaner, more open sound. And he started investigating it, and what it was reduced to was what became the APHEX Aural Exciter. So I wasn't there at that mistake. I was present for many mistakes later.
Well, okay, now, so I guess we're going to talk about this from a bit of a business point of view. How did you get yourself in, or how did you happen to get involved with, or get yourself involved with this mistake that happened to sound good? What I mean, I guess there's a lot of things invented this way. Somebody comes up with an idea, they're not sure what it is or if it's useful or not. Somebody else comes along and says, I can turn that into something. Let's form a corporation. Let's get together. Let me buy or license your technology, and I can make this commercially viable. What happened next after you heard about this?
Well, I was developing 180 acres of land in upstate New York. I was trying to build an alternative energy community, and that was in the early 70s, mid 70s, and people, I tend to do things too soon. I've had girlfriends who've complained about that. And so the problem was that I just couldn't make that happen. So I sold the land. I had this money, and in the meantime, I had met Kurt, and he told me with $5,000 we'd make $1 million. I have an accounting background, actually, so that sounded like a fantastic prospect. And I went ahead and did it. And then more money was needed, and more money was needed, and more money was needed. And then I found out that he had done the same routine to 2 other groups before he had met me. And at the time, I was 24. I was determined not to live the rest of my life regretting being a sucker. So I went ahead and learned the technology and turned it into a business. And what had happened was we didn't have enough money for production and actually selling the units. So we just had 5 units initially. And our initial concept was to rent it for $10 a minute of finished product. So we presented our first bill to Peter Asher, who had just produced Linda Ronstadt and that Hasten Down the Wind. And the album was 39 minutes long. We handed the bill of $390 to Peter Asher, and he laughed and he said, "Oh, you should charge 3 times as much." So we did. And it became just a standard. Now, you have to understand, during that time, Dolby A was becoming more and more popular. And if anybody remembers that time, it was referred affectionately as Dolby. And the Aural Exciter put the life back from into the audio that Dolby removed. So it was serendipitous that we came along just at that time. And we had literally thousands of albums that were mixed with the APHEX Aural Exciter. And it was so ubiquitous that on the Eagles' The Long Run, they actually put on their album mixed without the APHEX Aural Exciter.
Oh, gee, Renee. Oh, gee.
And I used that as demo material at all the trade shows.
Our audience here is mostly like myself, like Chris Tarr, like Tom Ray. We're technical guys, and we may or may not get this on the electron level, or maybe we do. But maybe you can tell us how the Aural Exciter works, or at least what is the end result of what's doing. And Rob, you can address, why is this a popular technology for producing records, songs, or why was it? Is it still, that kind of thing? Marvin, if you wouldn't mind first, give us as much in-depth as you can or feel comfortable doing about what the Aural Exciter technology is doing.
What it originally was as a high-pass filter, signal split into 2 paths, one going to output unmodified, the other path through a high-pass filter, a harmonics generator, and the output of the harmonics generator mixed back into the unmodified signal. The concept being is that how you generate the harmonics, that's really the magic. And earlier versions of the Aural Exciter, it was just amplitude dependent. And then as time went on, we improved it to make it transient discriminant, meaning that a high-level signal that was sinusoidal would not get a lot of harmonics generated, but a low-level signal that was transient, high rise time, fast rise time, would get more harmonics. So the effect actually improved over the years.
Now that discrimination between the high-level sinusoidal audio and a transient, I would not know how to design a circuit that could tell the difference in that. How did you get? How did you feel that? Or how did you come to believe that this would be a better product if it did what you just said? And then how do you go about getting that designed and testing it out and seeing if the idea really works out in practice?
Well, what's critical for intelligibility is consonant recognition. And if you look at a consonant, especially in English language, you have a fast rise time on the edge. And so that's the harmonic structure. And so the idea for us, and as well as anything percussive, you see that leading edge has that fast rise time. So piano, drums certainly, as well as speech. So we looked at how to build that, recognize that rise time, and send that information to the harmonics generator and get more output at that moment. And I guess you want to know who designed that particular circuit?
Oh, but sure, absolutely.
Well, that was our chief engineer, Don Werbeck.
I've met Don. Okay. You introduced him to me at a trade show one year.
Yes, and he's a brilliant guy. And a lot of that, Rob could speak to that musically, but I know we did a lot of testing with the Aural Exciter for improving intelligibility, and it actually does work. without adding level. And we've worked with, excuse me if I still say we. It's hard to not say we, but the company did a lot of work with the House Ear Institute out here in LA. And we did some wonderful work, and it just kept on leading me to more discoveries, particularly how it got me into the whole subject of listener fatigue. And I think that's a very important subject for the engineers out there who might be listening to this.
So, well, there's several different directions I could go off and ask some questions about this. You know, at the last CES show, I spent some time with the guys at the Able Planet headphone booth, and I talked to their designer, who had designed a really simple circuit. It's a fine wire wrapped through a toroid that ends up being in saturation and creates harmonics of the audio. And they claim makes the audio more intelligible at lower volumes. Let's say that I'm just not entirely convinced on their methodology. I think what you guys are doing ends up being more precise and controllable. But is there something to this notion that if we generate some harmonics of the audio that we're wanting to listen to, that we can indeed understand it better at lower volumes? And then the follow-up question would be, do people actually listen at lower volumes, or do they just enjoy, tickling more hairs in their cochlea and getting more excitation in their ears?
Well, at higher levels, you'll induce more listener fatigue. So one of the things that we found is one test in particular is hearing and noise test. And the more transients there are, there's more intelligibility. So you have more higher intelligibility in noise. So the point there being that you have the ability to listen longer at lower levels, and that's much more comfortable and still get the full experience. One very important story I tell that everybody relates to is leaving your radio on in your car at night, waking up in the morning, getting in your car and turning on the your car, and the radio's blasting. The point there is that your ears have unfatigued, the compressors have released, and you can hear again. When you do have listener fatigue, your acuity also diminishes. It's not just level. Your acuity diminishes. So the idea is to listen at comfortable levels that won't induce fatigue.
Well, I tell you, Marvin, I got to agree with you 100% on that point about your ears are tired, and you're right. It's like they have their own built-in compressors. I certainly have foolishly tried to set audio processing on radio stations late at night after I'd been working all day and listening all evening and listening hard for a long time. Get up the next morning and you listen to the same station, the same processing that you were kind of happy with last night, and you realize, ooh, I didn't make such very good decisions about that, did I? We better start over again.
I'm sure Rob could speak to the mixing process and listening back to stuff that he's mixed after working for hours and hours, coming back with fresh ears and having a different perspective.
Yeah, well, actually, the story that immediately comes to mind is years ago I wrote the music for the trailer for Godzilla, the Godzilla that came out in about 98, I think. And it was a loud trailer. In fact, it ended up redefining what loud trailers meant, and it made them create all these new rules for how loud trailers can be because this trailer was so loud. But the client just kept saying, we need it to be louder. We need it to be louder. Godzilla's roar needs to be louder. Then the orchestra needs to be louder. Then the footsteps need to be louder. And we had a mix day where we were in the room and the mixers were losing their mind because it just kept getting louder and louder and louder. And it got to the point where everything was just completely pegged. And the client was saying it's still not loud enough. So the mixers were starting to bleed. And they just said, you know what, let's take a break. Everybody left, went outside, walked around, took a break for about an hour, hour and a half. Came back in, and we played back the same mix for the client. And the client was just clasping their heads, screaming at how too loud it was. And it was strictly just a situation where the listener fatigue, our heads had compressed. I mean, our ears had shut down from this thing, and we were hitting like 110 dB. I mean, it was just ridiculous. Everything was pegged. And we ended up then being able to turn it down to what was just normally really loud, but it still redefined what a loud trailer was. And that's a very common mistake, is that people want to get a project done. So they want to keep working and working and working, not realizing that the product is really going to suffer. It gets worse and worse. Same thing's true with mastering. Mastering engineers who master too loud. You know, all of a sudden, you work on this, excuse me, you work on the same project for a few hours. Your ears start to get fatigued if you listen too loud. You're going to start boosting the high end, which is going to fatigue your ears even more. And then you're going to come out with a master that's just way too bright because you're trying to compensate for the fact that your hearing is going to sleep.
And another reason why the Aural Exciter was popular.
Yeah, well, I don't know if you want to go into it, but we can go into how we use the Aural Exciter because different people use it at different points in the chain.
I would like to hear that, Rob, from your perspective. What would lead you? Like, do you use an Aural Exciter on everything? Certain things? How do you decide when you first heard it? What turned you on about it? Yeah, tell us about, as a mastering engineer and as a producer, why you would want to add these harmonics that weren't there on the original audio.
Well, don't tell Marvin, but we don't use it on everything, just because everything doesn't need it. Basically, some people use the Aural Exciter more in the mastering process because it's a way, without increasing your level, it's a way to make things just pop a bit more. And to an untrained ear, it just makes everything sound sort of more present. And it's sort of like when you had a boombox and you turn on loudness contour and there's just something nice about it. This kind of does to the high end and to the present stuff, just gives it more presence and it makes it more clear or something, you know, which for spoken word would be understanding the consonants and stuff. But for music, it just, I've never played a mix for someone where when you put in the Aural Exciter, it just doesn't get a little bit better. It just makes it a little more present. You have to be careful not to overdo it. But it really, if you use it, you know, with the skilled ear, it really does make it better. That's one way to use it, is on your finished master. The way we use it more often than that is during tracking. Or I'm sorry, it's on the multi-track, but it's usually during mixing. Like we'll record a vocal, and a lot of times if you run the vocal through the Aural Exciter while you're mixing, it'll just help it poke through the track a little bit more without actually having to be louder. It just gives it sort of a presence, and I'm not talking technically, but it makes it seem to be more present in the mix without, you know, a lot of producers, if the vocal's not loud enough, they just make it louder, and then that's not the right way to do it. You want it to sit in with all the frequencies that are dancing around it, and you want it to be a mix. You don't want something to be louder just because you kept turning it up. You want the frequencies to sort of interplay better, and there's something about the Aural Exciter, especially on a vocal, but also we use it a lot on solo instruments too. We've used it on bass to get it to poke through. We've used it on acoustic guitar to give it like a shimmer. It's a really pleasing sound. In my mind, you don't want to use it on everything because the whole point in a mix is contrast of all the different things in the mix. So if you apply the same process to everything, then all you're sort of doing is a generic adjustment, which is really something the mastering engineer should do. When you're doing a mix, you're playing with the contrast between the vocal and the drums and the piano and the bass and the guitars and the orchestra. So we use the Aural Exciter sparingly where it's going to do the most good. And if the bass doesn't need the treatment, but the piano really needs it to sort of sparkle above the bass, we'll just use it on the piano. And it's one reason they sold so many Aural Exciters, because in a multi-track mix, there really could be 8 tracks you need it on or 16 tracks you need it on, especially in a 96-track recording, which is, you know, totally common these days to have that many tracks.
So how does the audio, after it's been run through the Aural Exciter, how does that hold up through things like audio coding, data, even data reduction coding for, you know, MP3 conversion, AAC conversion, things like that? Have you noticed any? Does it create more artifact? Does it pass through that fairly well? Does it remain pretty stable?
I've used it, and it's very stable, and I find that it actually works better on the decode. it tends to put some of the air back that is lost in that process.
Yeah, most of my experience would be with MP3s because that's what we generate. Use $1 trillion worth of equipment to come down to an MP3 file. I know we're all excited about that on a daily basis. But if you have the Aural Exciter in a mix, it does help the audio go through the MP3 compression a little bit better. I guess it adds clarity, and the whole point is going to an MP3 removes clarity. So the more clarity you have going in, the better it's going to be.
I suppose too, with the fact that, perceptual coding, we'll actually have you'll use some of that data that the Aural Exciter generates to remove that. So in some ways, I suppose it gives it some extra audio for it to play with as it's doing its data reducing too. So another question I have for you is, and this is more just a question in general with using things like the Aural Exciter in audio production. Do you ever take into consideration where the audio is going to go or where it's going to be played back in terms of what kind of spice you put on it? For example, running it through an Aural Exciter, if it's something for radio, there's a chance that it may go through it again in the process of being put on the air. Is that kind of still your thought process when you say, we use it on some things, we don't use it on others? Is that what part of what goes into the decision, is where the final product is going to be played?
Well, from my perspective, yes, because we mix for a lot of different media here. We mix for movie theaters, where everything you do is going to be heard through horn speakers. That's very different than mixing things that you think 15-year-olds are going to listen to on their iPods, which is very different from listening for television. I think the more of a restriction we have on our levels, like when we do broadcast television stuff, our headroom is really collapsed. We don't get a lot to play with. The Aural Exciter can help things poke through. I probably use it there to hopefully preserve sound when we know that it's going to be degraded by the way it's broadcast or the way it's compressed to MP3 or any of that. In a theater, it's a different situation. A lot of times, because we know the way horn speakers are going to react to our mix, we'll use it to make certain things sparkle a certain way. From a creative side, we absolutely think about the medium that it's going to. And we, like any studio these days, we're set up to listen to every one of these potential listening environments, because it's just amazing when you listen to something that's a YouTube compression, you listen to that versus what it would be on a regular TV speaker or in a theater. It's completely different. And the Aural Exciter, because it's adding to clarity, it works for all of these, but we just have to check it on each.
I was thinking with narrower band audio channels such as AM radio, where it's really not the transmitter, it's more the receiver where you have a problem, or maybe some communications link or something. I don't know. You might have a narrow band link and unequalized phone line if they still do those these days. Would there be any applications for the Aural Exciter in that? How do you think it would handle the narrow band channel?
Well, if you're talking specifically about AM radio and probably referring to talk, I would tune the Aural Exciter on the 230. That's our voice excuse me again, I keep on saying our. It's the voice processor that has the Aural Exciter and the big bottom included onto it. And that way you can tailor it to the voice, and it will give that additional presence, that pop out of the dashboard, if there are speakers on dashboards anymore. But so your ankles hear better audio.
Hey, actually, Marvin, I'm with the family. I'm actually on vacation. I'm staying at a friend's house in South Carolina, and he's got a home studio. And actually, I've been helping him, set the home studio up. I come do a little maintenance every now and then. And we've got an APHEX 230 mic preamp and channel here. So I've been playing a lot with the I guess it's a tune and a mix control for the Aural Exciter function. Tell me, what is the tune control doing? Is it doing something more complicated than I'm thinking? It's just choosing a band of frequencies to make harmonics of?
No, it's setting the corner frequency of the high pass.
Okay, so this is a high pass.
So as you tune it down, you're putting more into the Aural Exciter. As you tune it up, you're tuning less. That's why I'm saying it's very, very good to tune for actually not just the announcer, but actually to a microphone. And RE20s in particular sound marvelous through the 230. Because they don't have, the RE20's wonderful sounding, but it doesn't have a lot of presence. It's a great device, and you could hear the Aural Exciter work. But it's not just the Aural Exciter in that box; it's also wonderful compression. Again, it's compression that preserves the transient, and there's a wonderful gate that doesn't click or pop, and the big bottom gives real balls to the voice. I noticed Leo Laporte was on just before we got on, and that's his mic preamp. And he's been loving it for the last 4, 5, 6 years.
Gotcha. Yeah. In fact, after the commercial break, we're going to talk about the big bottom technology. It's kind of fun to say, but I want to know how it works too. So actually what Tom was kind of driving at, and I was curious about the same thing. But before the show really started, we were talking about ham radio, and I was just curious if you could improve intelligibility over a really narrow band channel. So if you tune the Aural Exciter to have a lower corner frequency on the high-pass filter, can you get harmonics in the 3 and 4 and 5 kilohertz range, not just up in the 7, 8, 10 kilohertz range?
Understand the high-pass filter is 6 dB per octave, so it's not a heavy cutoff. So you're still getting a lot of low frequencies into the harmonics generator. So nominally at 12 o'clock, that position is around 3K. So even if you tuned it down, what you don't want to do is make it sound unnatural, even if you're listening on a very narrow band. I know the 230 would work fabulously well on ham radio.
All right. Wow. Hey, APHEX 230s for everybody.
I can't say that anymore. But can I just make one very, very important comment? People use outboard preamps, take the output of the preamps and put them into what is labeled on a mixer line in. And more often than not, those line ins are just padded preamps. So go into the insert return, and it'll sound infinitely better than anything else, because you're still listening to, when you go into the line in, you're still listening to the crummy preamp that you were looking to improve.
You know, that's a really good point, and something that actually both you and Rob can probably address. If you deal with, and I'm not saying these names because they're bad or anything. In fact, I know these companies have put a lot of work into it, especially Mackie has. But if you have a Mackie mixer or a Behringer mixer or any mixer where you've got a trim control and you can trim it all the way to mic level or all the way up to line level, guess what? You don't have a really optimized item there for a line level input. All you're doing is cutting the
a crummy line input stage will sound better than the greatest preamp as an input stage. So you want to just do line in. Make sure you get into a line in.
And that's why he was saying if you have an insert return, that's often a line in that has no trim on it. So that's the purest input to use if you have an insert return.
Right. Now, unfortunately, a lot of insert returns are unbalanced.
So
what? Doesn't matter as long as your grounding is good?
Yeah. I mean, it's a short run. You're not going to wrap it around your transmitter. So, just pop it in.
You know, actually, this subject of knocking a line level down to a mic level just to bring it back up again is something I discovered years ago in a console made by Broadcast Electronics. They advertised every channel can be mic level or line level. Well, yeah, that's because every channel was a mic preamp, and they just put a pad of, I guess, 3 resistors in front of the mic preamp so you could run a line level into it. But I noticed, man, this console sure is noisy. Well, yeah, it was noisy because everything got cut all the way down to mic level and then boosted all back up again from the mic preamps, and they weren't very good mic preamps. Did I notice the right thing?
Yes, you noticed the right thing.
And he's not kidding. He talks about this all the time. This is one of his bugaboos, definitely. And it's true. Well, I mean, all you have to do is compare the sound quality when you're knocking a signal way down and then bringing it back up. I mean, it's actually clear enough that you can hear the difference in a trade show environment, which, there aren't many audio things that are that big of a difference that you can hear on a noisy trade show floor. It's amazing how many people buy really expensive preamps and then have them running through a gain stage like that. It's terrible.
Yeah. So it's in the chat room, somebody asked, why wouldn't it be cool to have the Aural Exciter technology in people's receivers? And that way you could tune, the listener could tune in how he wants. Not that the average consumer is maybe sophisticated enough to do that, but right now all we have is bass and treble or multiband EQ controls. And Marvin, I'm sure this had to cross your mind at some point. Why don't we try to get this tech into receivers?
I tried a number of times getting it licensed, and I just wasn't successful, bottom line, in getting it widely accepted. We got Yamaha, and there's some other companies that are put it into a few professional devices, but I just wasn't able to crack the consumer market. It's one of my regrets, because that would have been a very nice income stream.
Sure, I guess though the consumer market, if it costs more than 3 cents to put into something, it's got to be really something that people are banging on the door to get.
Well, no, there are technologies that have gone out there, and I won't name names, but a lot of them are just pure BS. And but they had the name and some consumer demand.
Gotcha. I sure have noticed, and I'll name a name because I'm asking a question about the tech. I've bought, stereos and car stereos that have something like SRS Wow in them. And, you engage it and you hear some interesting effect that, isn't – I don't want to listen to it all the time, but on some songs it kind of pumps things up and sounds pretty good. Is that the kind of tech where companies like that have gotten into receiver manufacturers?
Yes, exactly. Okay. And that's all just phasing and EQ.
Yeah. I didn't think it was any more magic than phasing an EQ, not in a $159 receiver. So.
Mm-hmm. But don't be put off by cost per se. And if it's a digital, a few lines of code, most manufacturers now have some DSP in it. And they'll just put the EQ, level control, and things like that into the DSP. And gotcha. That was always my dream, but not to be.
Gotcha. Well, let's see. Hey, it's time to take a little break. I want to remind our viewers and listeners that you are watching or listening to This Week in Radio Tech. It's our 121st episode, and along with me are my two normal partners in crime. That would be Tom Ray from the Hudson Valley of New York.
Hey, Tom. I am not normal. Talk to my wife.
And also Chris Tarr is with us from Muckwonago, Wisconsin, and he's with Entercom there and runs a great little website called
BroadcastEngineering.info.
BroadcastEngineering.info. Our program today, our guest, Marvin Caesar, and also Rob is with us, and we're going to take Rob, I'm sorry. It took me 7 months to pronounce Muckwonago correctly. So,
well,
Arbittier.
Arbittier.
Yeah. Arbittier. That's such a great name. I need to get it down.
Actually, half the family pronounces it Arbiter. So as long as you're close, it's fine.
Well, Arbittier sounds a little more French and a little more sophisticated. Let's tell you about who our sponsor is on the show. It is my employer and also my friends at Axia Audio. In fact, this very show is coming to you through a console made by Axia Audio and the IP Audio Livewire technology that is built into it. Axia, a few years ago, was the very first company to actually have a workable solution for putting low latency, unbuffered, uncompressed linear audio across an IP Ethernet network. And this is not something that is not standards-based. In other words, it is standards-based. The folks at Livewire were able to put together a bunch of standards, add a little bit of magic in the form of some accurate timing between and among the devices on the network, and come up with a way to run audio, stereo audio, even multi-channel audio across a standard Ethernet IP network. Going through standard Cisco and even some HP switches, you can connect studios together. You can build individual studios. And for example, at the TWiT network, they have an Axia Element console. That's the main console at TWiT, where they do all the mixing. My voice is going through that right now. They're also creating mix minuses on the fly and automatically. So each of the participants in this very podcast and all the other netcasts that are on TWiT can hear each other without hearing themselves back delayed. That's what a mix minus will give them. The Element console that they have is tied via a gigabit Ethernet connection over to Leo Laporte's studio, where he has an Axia Radius console. This is a small standalone console. It has an Ethernet switch built into it, so it's very easy to plug together, plug accessories into it, plug things into it, like when Leo gets a Telos phone system, he'll be able to plug one of the Telos VSET telephones right into that console, and it'll even provide power over Ethernet to the phone. Now there are over 3,000 Axia consoles in use, on the air, or in production around the world. All these IP audio channels flying around, just literally tens of thousands of IP audio channels working every day in countries all over the world. So if you're thinking about an audio console for your radio station, that's what they're designed for. The features are designed for radio. You might have other uses for them as well, like remote or OB vans. You're going to check out the consoles, the Element, the IQ, and the Radius at the Axia Audio website. The website is axiaaudio.com. And there's the Element, the IQ, and the Radius. Please check them out. There's also, by the way, other things that go along with consoles, like our intercom system. You can plug these intercom panels directly into switches on the backs of the consoles, or separate Ethernet switches, and have yourself a really fancy intercom system throughout your facility. Check us out also at the NAB show. If you'll be there, we'll be glad to see you at the booth in the Central Hall at the Las Vegas Convention Center for NAB. Thanks to Axia Audio for sponsoring This Week in Radio Tech. Oh, there you go. There's Leo's console. That's the Radius. All right, back at it here. We're talking to Marvin Caesar and Rob Arbittier. Rob Arbittier. At least you're not from Mukwonago.
You know, we should have a contest tonight. We ought to give something away for every time you mispronounce his name.
Actually, every time I mispronounce his name, I'm having a sip of. Can I say what this is? This is Firefly iced tea, vodka, and lemonade.
Now we know the secret.
Well, I was going to say that explains why we're mispronouncing it.
Before you started.
Probably why I can't say Arbittier, huh?
There you go. You did it.
Hey, we ought to move on to what Marvin alluded to a moment ago, because just earlier today, I was working with my friend Roger. He's the voiceover artist here, and it's his studio. We were adjusting the big bottom. Now, I noticed there were a couple controls on there. Marvin, what was I adjusting, and what should I be listening for with the big bottom when I'm playing with it? Oh, I guess we should start with what is it and what does it do?
Well, the big bottom splits the signal into two paths, one path going to output unmodified, the other path through a low-pass filter, and then into a compressor, and then return back into flipped in phase and then mixed back in. The concept of the big bottom circuit is to add fullness on the bass without increasing the peak. So the idea is that the leading edge of the bass is left alone, so it isn't masked. So the attack on a bass guitar is still there. The voice, again, the intelligibility on the consonants, still there. But the big bottom, when used properly, gives a richness and a resonance to the bottom end that is completely natural. If you'll know that if you've used too much, if it becomes muddy.
So we're adding bass, but it's not like you're just bumping up the EQ control. You're actually adding density, and you're actually adding more bass. How does it not get smeary if you're adding the right amount?
It's just a small signal, a very steady level signal, that compressed signal. So when the bass is very high going in, the amount of added signal is very small. As the bass decays, it just builds the release up, the decay up, so it's fuller.
Are there some particular?
It's dynamic, so it just works more when you need it. That's impressive.
So when you got plenty of bass, it's not doing very much.
Right.
Gotcha. You could probably somebody's probably already sloganized that. It works when you need it. Are there some instruments like dub, bass guitar that this might be particularly effective for?
Well, one of the things that happened when we introduced this to Nathan East, who's one of the top bass players in the world. He loved it so much he wanted to take it with him, and we said that's the best we could do is give you this rack unit. But we made another left turn in our business plan and started doing instrument pedals. And the prime users are still bass players.
So let me see if I can get some clarification. What the Big Bottom is doing, is it more than just a single band processor? In other words, is it adding some more fill in there, or is it simply adjusting level instantaneously in a way that's pleasing?
It's not touching the input. The input goes through unmodified. It's just a compressed signal added back into the signal so that the proportion of the enhancement signal is greater when the input is lower. As the input goes up, the effect is diminished. The proportion is diminished. So the idea, and again, what's very, very, very important is it doesn't screw with the leading edge. And that's why bass players love it. They love getting fat, big bass, but they don't like losing the attack. And if you did that with, it has the same effect on level, I guess, as a multiband compressor, but the multiband compressor would screw with the attack. Yeah, it would put, once you're up at a high level, and you put more level in, it pushes the attack down. And if you talk about a broadcast processor, which everybody who's listening to this, you just get a muddy bass with no definition. The whole idea of this processor is to maintain the definition.
Rob, tell me how you would use this Big Bottom effect.
I mean, in our practical application, we don't usually use it on synth bass, but on any sort of bass guitar or any kind of low instrument like that, it almost seems to give you like an additional octave down. I mean, I really appreciate it once we had rebuilt the studio with a really good sub and a really balanced room. It just felt, the bass just felt rounder, and it's not like it can be used in so many different applications like the Aural Exciter to me. I mean, it's useful in a few applications, but it just really rounds out the bottom in a part of your mix where not too much other stuff is going to live, at least for the kind of music we do usually. And I guess the easiest way I can describe it is it almost feels like it gives us another octave, and it's probably just because it's clarifying and tightening up what's there. But it definitely, as long as you don't overuse it, it's an incredibly pleasing sound. It is easy to overuse because you hear it and you like it. So if 10% of it's good, 20% has to be better, and 40% has to be twice as good as that. You have to get away from that, and you have to keep A being what it's doing without it, because it's very easy to sort of fall in love with it and say we need more and more and more and more. Like Marvin was saying, if you overdo it, it will start to smear things up a bit. But it's an incredibly pleasing sound. It's not something we've ever used on a whole mix. Use it for a source instrument kind of thing.
What's so terrific about the Big Bottom for voice is a lot of people on microphones don't have a perfect headset. If they're using a headset, obviously it is, but if they're using a mic and they're reading and they're off mic, they're on mic, as they're on mic, they have more proximity effect. So you have more bass. And then they're off mic, you lose some of that. What the big bottom does is it fills that in, so you have less of that effect. So it actually allows a person to work a mic much more easily.
Another thing we do is we tell our singer to stand still. That works too.
whatever you need. But what was really interesting was when I first had a prototype, I went to Michael Reagan's studio, and he always had a very thin voice, not very ballsy. And so he was always working it, and he developed polyps on his vocal cords. Mm-hmm. And he had just come back from surgery, and his voice was even weaker. And I set up the 230 and adjusted the big bottom. And after he was listening for a while, I could see his entire body relax, and he allowed himself to go back in his chair. So he wasn't worried about how he was sounding. He was more worried about what he was saying, which is a good thing because he was still talking drivel. But
anyway. You don't have a box that fixes that, right?
No, there's no drivel. There's no drivel cake thing. Cake.
Oh my goodness, gosh, man! I guess I'm still trying to figure out applications. I mean, I know that producers want to use this in music, and I suppose in movies. Certainly, I almost believe I hear maybe an overuse of the aural exciter in things like movie trailers. I'm thinking, man, that's more than an EQ, and then nobody's voice is exactly like that. Do we, as consumers of ordinary audio, do we hear aural exciters every day on half the commercials we listen to, or a lot of the audio that we were exposed to?
I would say what you're listening to in terms of unpleasant distortion is an awful lot of aliasing distortion. When you have an MP3 file, and we get back to everybody crunching for maximum loudness, you have people going up to 0 dBFS and linear files and then converting to MP3s. And with all the filtering and the reduction of harmonics, you have all these overshoots, and they generate a tremendous amount of aliasing distortions.
And so, I wasn't actually complaining about what I was hearing. I seems like on certain spots, a lot of national.
If you notice it, it's too much.
Ah, okay, all right, interesting. What about in Rob? Have you got experience with doing movie soundtracks, sweetening for movies, that kind of thing? Is this
sure.
in use in film?
I haven't seen it in use in film as a mix tool the same way you see it in music. I definitely know of people, like very creative sound designers, who use it as part of their chain when they're creating the effects. Mm-hmm. Generally, when you're mixing a film, I mean, I guess in a film you could see using it on a dialogue chain or something like that. But if you're juggling, 700 tracks or something behemoth like you would on a big blockbuster action movie, I haven't usually seen them use it like on the effects or the music. Generally, the composer's team would use it in mixing the music that they deliver to the stage, and the sound design team would use it in creating the effects that they deliver to the stage. I don't know if it's as prevalent in the actual final dub of the film. I could definitely see the dialogue mixer using it, and actually we used it on a film here that was a film that was recorded with a crew in Russia, and the booms and things they used, it seemed like they had all the mics pointed in the opposite direction. Everything was very dull and horrendous. We ended up using the aural exciter for that to try to bring some presence back, because it's definitely one of the best secret weapons for that. Not so secret, really, but I don't know that it's as prevalent on dub stages, though, that it is in music and creation studios.
Actually, there's a great history with Dolby. The Aural Exciter was used extensively on the movie Grease, and that was when Dolby was trying to get their dominance in the movie business, in the cinema business. And they gathered a lot of engineers together with in a theater and set the Aural Exciter to stun and said, see, you can't use that for the movies. And so we had a hard time getting equipment into the film business after that for quite a few years. So thank you, Ray.
So we couldn't close out a show without at least spending a few minutes on a technology which is in a product that so many broadcast engineers are familiar with, and that is the APHEX compeller. You go into any radio station, especially any radio station in the late 80s, all through the 90s, and even to now, although I probably see fewer of them now, and that is the APHEX compeller. In fact, let's say, Tom, Ray, have you got an APHEX compeller at your shop or any of your shops?
Oh, I've got a number of them. I'd like to find out exactly what the thing does, because you can't hear it do anything, yet it protects all. I've got it in front of all of my STLs, and if I pull it out of line, forget it. The station just doesn't sound right.
Chris, Chris, go ahead.
Same thing. I've got several of them, and I use them religiously. And I agree with Tom. You sit there and you go, well, you know it's working, but you really can't tell what it's doing. You just know that it's there. And it's really kind of it's almost black magic in that box.
And if you take it out, you miss it.
Yeah.
It's truly transparent control. And that's one of the marvelous things about it. What the compeller is a combination of compressor leveler, and hence the name compeller. And what it does, it's combining high ratio leveling. That's an old picture. Wow, that's the original compeller.
That's what
that's what we all have in our radio stations, Marvin.
Yeah, right.
But I'll tell you something.
I have
unfortunately, we didn't go. We weren't run by marketing per se. So unless something was really an improvement, we didn't change, and that's why the stuff that you bought in the '80s still working. And maybe, I should have done more marketing-oriented design, but if we couldn't find improvements, we didn't do it. But anyway, the idea of the compeller is to combine a high-ratio leveler with a lower-ratio compressor. And the idea being that there were three controls on the compressor, on two controls on the compressor and one on the leveler. There was a dynamic verification gate so that the compressor wouldn't release, and that floated. It's very similar to a silence gate, but it was floating. So as a signal went down, the compressor wouldn't chase it, and then wouldn't have to chase the the onset. So again, getting back to the transients, it was very open. The transients would just float through. There was also what was called a dynamic release computer, and what that would do is vary the release time so that it would hold the release beyond the dynamic verification gate, and it would speed the release when it needed to, or slow the release depending on the texture of the input. So that's why you don't hear it. And on the leveler, one of the improvements was that's a newer version. That's a 320D that went into the digital world. The last improvement we had on that was what was called a frequency discriminant leveler. What some people had done was high pass the detector circuit into the leveler, which would diminish the amount of pullback that you got on bass, but it wouldn't give you the right amount of leveling. So what we did was we adjusted the attack time of the leveler so that made it dynamic. So when there was a heavy bass transient, we'd let that go and then pull it back. So those were the three inventions in the compeller.
One of my first introductions to the APHEX compeller was I was visiting a radio station. I guess it's okay to say I was visiting FM 100 in Memphis, Tennessee, and I was talking to their engineer at the time about some Omnia audio processing as their on-air processor. And we're standing in front of the racks, and the engineer looks over at the rack and he says, "Oh, I guess Tom Prestigiacomo's on the air." I said, "Well, how do you know that? By what time it is?" He says, "No, look at the compeller." So apparently, one of the biggest things that the compeller would do for a broadcast engineer and his operation is that, disc jockeys, a lot of them are pretty notorious about not watching their levels. They'll run things way too low, or more typically, they'll run things way too hot on the board. But they'll be very inconsistent one way or another. And the compeller is the box that would take that inconsistency and bring it under control into a range of consistency so that then the on-air audio processing system could more sweetly deal with it.
But that's exactly what it was designed to do.
And that kind of goes back to the Optimod, Orban Optimod 8100, which has a very notorious sweet spot between about -9 and -11, -12 dB of gain reduction. And as long as you could keep your audio right in that slot there, the Optimod sounded fantastic. The problem is, in order to get that kind of control, generally you'd have to really squash your audio. And so for a long time, and you still see this in a lot of smaller stations, one of the most popular combinations of equipment were either the Texar Prisms or the compeller into the 8100, because you'd be able to pretty invisibly keep your audio right in that sweet spot on an 8100. And, like I said, they were fantastic for doing things like that. And what's great about them now is, as we've moved on to digital processors, we've been able to repurpose those compellers for things like, POTS links, remote gear. They're very versatile little pieces of equipment in use everywhere for those sorts of things when you need some level control, but you don't want to do it audibly.
Yeah, it was a great piece of equipment, and a lot of people still don't relate to what process balance is. So I'm looking at Rob's compeller, and I set it up a few years ago, and he's just left it.
Still set that way. Guilty.
Well, why mess with it? If Marvin came along and set it up,
Exactly. You wouldn't want to mess with that.
What's going to be better than that? Hey, guys, I'm afraid to say we are out of time. We have gone on for an hour here, and it has been an enjoyable one. I've really enjoyed, Marvin, getting to reconnect with you and hear about the technology behind, the Aural Exciter. We talked about the big bottom, and finally the compeller. And Rob Arbittier, great to talk to you and find out about how these technologies actually get put into use in music production and other sound design, commercials, and even film. But it's all intended to make audio sound better and more pleasing, to make it, I guess, cut through the noise of everyday life without sounding bad in cutting through that noise of everyday life. Would you say that's a fair assessment?
Yeah, and it's been doing it for a long time. I mean, if there was something better, we'd be talking about that. It really set a standard many years ago, and there have been all kinds of people trying all kinds of different things, but there's some magic there. It really is.
I need to thank my co-host, Tom Ray from the Hudson Valley of New York, for being with us. Tom, thank you. Appreciate it very much.
Hey, I appreciate being here, and it's been an enjoyable hour. It really has. Thanks, Marvin.
Thank you,
I've got to get my hands. I've got to get my hands on one of these APHEX 230s, like I have here in this studio where I'm doing some work. But I want to hook one up to my ham rig and see what I can do with that. A little big bottom out of there, and gets the Aural Exciter. excitement going on.
Well, there you go. And I'd be happy to help you set it up. It would be a treat for me.
All right. And Chris Tarr has been with us from Muckwanega, Wisconsin. The Entercom station's there. Thank you, Chris. Appreciate you.
Thank you, Chris.
It has been a pleasure.
Great.
All right. And our guests, Marvin Caesar and Rob Arbittier. Did I get that right, Rob?
Thank you. Yes, you did. Thank you.
It took you an hour, but you made it.
Yeah. We should have talked more before the show. Thanks, guys, so much for taking an hour out of your day for being with us. I appreciate it very much. Thanks also to our sponsor, which is Axia Audio, on the web at axiaaudio.com, inventors of Livewire. And if you're at NAB, you're going to hear some really cool announcements from Axia. So please stay tuned for that. We'll announce it as soon as we can. Hey, thanks to Burke back in Petaluma, California, for switching our show. And thanks also to Leo and his vision for the TWiT.tv network. For letting us put this kind of technical information out to the world where broadcast engineers can see it, view it, enjoy it, or hear it every week of the year. Thanks, everybody, and we're going to bid you adieu. We'll see you next week on This Week in Radio Tech. Bye-bye.